So in the previous video, what we did was that we found the volume of the solid of revolution obtained by revolving this area from 0 to pi around the y-axis. Now what we are going to do is that we are going to handle the same question in the situation when the axis of revolution is not the y-axis, but it is the line x equals 4. Okay, so let me just make the slate cleaner and go with the calculation after that. So again, we are revolving this region about x equals 4. Okay, and then so we shall take an element here. Then the solid of revolution for this basic element would be a cylindrical shell, and if we are here at xy, the altitude of this shell is still y, but the radius changes, right? Earlier our radius was the distance from y-axis to the basic element, but now it is from x equals 4 to this element. So let's see what r will be, the radius here. So first notice that this distance right here is 4, okay, and then this distance from here to the element is how much? About x. So here we have this as x, and this right here is 4. So what we have is that this radius r is going to be how much? 4 minus x. So what we will have is that we are going to integrate from 0 to pi as before, and then we will have 2 pi according to the shell method. And for the radius, what we have? The radius r is 4 minus x, and then we will have times y dx, which is going to be 0 to pi, 2 pi, 4 minus x, and then y is how much? X sine x. All right, and then we can go ahead and calculate this integral. And in case you have to give the exact answer, you can use the integration by parts as before, and the answer would be this. Or you can always use your calculator in case you just have to give an approximate answer and obtain an approximate value like this. Okay, now let's take a slightly different situation. Okay, that is our axis of revolution is still x equals 4, but now what we want is that we want our region of revolution is bounded by y equals x sine x and y equals sine x between 0 and pi. So let me go ahead and enlarge this graph so that I can draw a little more easily. Here is a bigger picture. What we are trying to do is that we are going to revolve the region bounded by, again, these two graphs, and this is split in two parts. One is this where this y equals sine x dominates over the graph of y equals x sine x, and in the other part the situation reverses, that is this one is the dominant graph and y equals sine x goes below. So let's go ahead and set up our integral now. Now before we go ahead, we have to look at the points of intersection. Now two of them are like really apparent here. One of them is 0, the other one is pi. All right, and let's obtain this one. It looks like 1, but we can just quickly verify. So we are looking for the solutions of x sine x equals sine x in the closed interval 0 to 2 pi. So as I said, two of them are very clear. They are 0 and pi, and here we can move this to the left hand side. So what do we get? We get x sine x minus sine x equals 0, and then x minus 1. If we factor the sine x out, that's what we get. So when sine x is not equal to 0, x will be 1. So that's the only solution when sine x is not equal to 0. So what we got here is that x equals 1 here. Now what is going to happen is this. For an element here in this portion, we will have the altitude of the cylinder. How much? X sine x minus sine x. Okay. Oh no, actually that's a mistake. Here sine x is the dominating graph, so this is positive and this is negative. On the other hand, if we go to the green portion of the graph, all right, then the situation will just reverse. Why don't I do this? Instead of torturing you with my handwriting, or bad handwriting actually, just bring it in type, that here the situation reverses. So what we have now is that the region obtained by revolving the yellow area is integral from 0 to 1, okay, of the expression here, and the region for the green area will be, of course, the limits will change to going from 1 to pi, and these signs will reverse, so that you have the positive value for this altitude. Now when it comes to evaluating the integral, you can always do integral by parts and obtain the exact value like this, okay? And I'm not going to ask you to find exact value, and if you don't have to find the exact value, you can just put that in your calculator, and there you can do it directly, because here you can just do this, go straight from 0 to pi, and just put absolute values here, okay, and ask for the approximate value. That's what you will get, which is again just the approximate value that you have here. All right.